Silicon carbide is no longer one thing, it's splitting into everything. Silicon carbide used to be simple. It was the EV material. Better efficiency, faster charging, Tesla uses it, and that was the story. But today, if you want to describe silicon carbide in one sentence, it gets slightly more complicated because it's no longer one thing. It is starting to split into several different directions at the same time, and the industry is still adjusting to that. The first phase of silicon carbide was very straightforward. Electric vehicles drove demand. When companies like Tesla started using SiC-based power devices, it sent a clear signal across the entire supply chain. Capacity expanded, forecasts scaled up, and for a while the logic was simple. One material, one application, one growth curve, almost too clean in hindsight. Now the situation looks a bit different. EV growth is still there, but just not at the same linear trajectory people originally assumed. And on top of that, silicon carbide supply has matured. More capacity, more players, more competition. And in almost every industry, when that happens, one question inevitable appears. Okay, what else can this material actually do? Alright, a simple way to understand silicon carbide today, instead of thinking of silicon carbide as one material, it helps to think of it in three roles across the system. Not necessarily different versions, but different jobs. Let's start with the device layer, which is basically the original EV story. This is single crystal silicon carbide, typically grown using PVT method, then processed through epitaxy and device fabrication. This is what powers EVs, industrial power systems. It is the most established and scaled part of the ecosystem. This is the original identity of silicon carbide. Then you have the infrastructure layer, CVD silicon carbide. This is where things expand beyond devices. CVD silicon carbide is used in two established ways. Epi or epitaxial growth for device fabrications, coatings or bulk for semiconductor equipment components. Things like reactor parts, wafer carriers, furnace chambers. So instead of being part of the final product, it becomes a part of the factory that makes the product. And that is a very different role. It is not replacing anything, it's operating at a very different layer entirely. You could say it is the infrastructure furniture of semiconductor manufacturing, just a very expensive kind of furniture. And finally, you have the emerging layer, where things get messy, but in a good way. This is where silicon carbide starts to appear in very different conversations. Not necessarily as a unified mature market, but as a set of early and experimental directions. That include, for instance, RF and defenses. Semi-insulating silicon carbide is being explored for RF systems, including defense and high-frequency applications. Optical grade silicon carbide, which to a certain extent sounds like a marketing term, because in many cases the definitions are still evolving and specifications are not always clearly standardized. So this is still more direction than established category. XR/AR systems. This is a good example of how far the conversation stretches, because it appears in discussion around thermal constraints, compact system design, and high-density integration challenges. Advanced packaging and interposers. This is another area that comes up very often. In advanced packaging, including interposers and co-packaged systems, silicon carbide occasionally enters the discussion. To my knowledge, not as a mainstream interposer material today. Most interposers are still silicon or organic substrates, but silicon carbide is being explored in early stage research for thermal stability, high power density environments, and extreme reliability requirements. So again, not a replacement story, more of a what is physically possible under new constraints exploration. Let's have a look at the real shift, the core insight. So what is actually happening? Silicon carbide is not becoming obsolete. It's becoming fragmented. It's no longer defined by one single application or one single market direction. Instead, it is being interpreted differently depending on where you sit in the value chain. EV power electronics, semiconductor manufacturing infrastructure, and emerging system-level exploration. Essentially same material, but very different meanings. So at this point, silicon carbide is not really a single market anymore. It's more of a collection of markets that all happen to share the same material name, which is interesting from an engineering perspective and slightly inconvenient if you're trying to build a clean forecast model. So the real question is no longer how big is silicon carbide going to be, it is which silicon carbide are we talking about? Because depending on who you ask, you're going to get a completely different answer.